All right, so today we're sort of doing two different things. We're looking at transformations, and but we're going to look at it in two ways. So how do transformations impact graphs and like the equation and the relationship between those two? But then also thinking about how transformations, what they do to just points. And I think some of you, or maybe all of you, have actually seen this. So some of this will be review, or all of it will be review. I think yesterday, and if you printed this out, are your letters different from the letters that are up there? Does anybody have a C? No, you have the right one? Okay, good. There's no standard about these letters, A, K, D, and C, unfortunately. In grade 10, this is H and this is K, and then in grade 11, the K moves here, like it's the same letter, but it means something different, right? It's not like the shift moves to a different spot. No, the K is not the shift anymore. Some textbooks use P and Q here instead. Another grade 11 textbook uses C and D, but flips them. So it's very confusing. So I'm used to using C and D the other way. So sometimes if I write it down that way, that's just because I'm going back to the way that I'm used to doing it. But this is, I figured we'd stick with this way because this is how your textbook does it. So it's got the D inside and the C outside. Okay. Okay, so you've got that right. So here we go. We've talked a little bit about this, but we're going to do it formally now. What are all of these things? So we've got A. Could be a reflection in the x-axis, right? If A is less than 0, if it's negative, in other words, and it's a vertical stretch if A is, if the absolute value of A is greater than 1. We know that notation now, so we might as well use it. So if the absolute value of A is greater than 1, what does that mean? Well, if it's 2, it's a vertical stretch. But if it's negative 2, it's also a vertical stretch. It's also got a reflection, but it's a vertical stretch, right? So 2 or negative 2 will both give it a vertical stretch. So the easy way to say that is the absolute value of 2. And it's a vertical compression if the absolute value, of A is less than 1 and not equal to 0. So if it's a fraction or a negative fraction, like smaller than 1. Okay. And K is a reflection in the y-axis, and it's a horizontal stretch or a horizontal compression when? When the number is greater than 1, it's which? Horizontal compression. Okay, so that's absolute value of K greater than 1. So it's opposite of the other kind. Thank you, very good. And the absolute value of K is less than 1 is when it's a horizontal stretch. So just like shifts that you learn about in grade 10, and you do more in grade 11, just like shifts, when it's inside the brackets, it has the opposite effect of what you would expect. Our common sense tells us if I'm multiplying by 2, it's going to make things bigger. Turns out it's not. Or not, at least not in the way we expect. Okay, D. It's in the brackets, so it's horizontal. Shift. And it goes right. This is tricky. because in here it's minus, if D is positive, okay, that would look like x minus 5, which would be a shift to the right, right? Opposite impact. But D is 5, right? Like D is 5 because you're already subtracting in the formula. So it goes a horizontal shift right if D is greater than 0, and it's a shift left if D is less than 0. But that's opposite from what's in the brackets. So I'm sure you all know that because that's a big deal. That's something that people get very used to. Just keep that in mind, that it goes the opposite way of what you see in the equation. But my D value is also opposite of what you see in the equation, I guess is the way you would say that. So the value of D matches the direction that it's going. Okay? And then C, same thing, but that's a vertical shift. Okay? And same thing, it goes up if C is positive, and it goes down if C is negative, just the way that you would expect. We also call these translations. You can use either word. We're going to do some examples of this, but we're picky about how we say it. So you're going to have to say it the right way. So we'll do a learning goal on this, but if you get feedback that like you said it wrong, I don't know what to tell you. You said it wrong, and you're not going to get marks for that on a quiz or a test. So keep that in mind. Don't make up your own way of saying it. So it would be something like a vertical stretch by a factor of 2. It's so picky that if you said a vertical stretch by 2, that's wrong. Because the whole point is it's stretching because there's a factor. That means multiply. That's an important word in that sentence. By a factor of 2. Whereas if it's a shift, you would just say a vertical shift up 2. Because every point is moving up 2 the same way. If it's a stretch, every point is moving by a factor of 2. It's doubling. So it depends on how big it is to what the change is. Yeah.
Do you want us to write out like vertical stretch?
Yeah, you would have to say that. No, you should write it out. The whole point is you're writing it out in words. Yeah. Okay. So what does this mean? If we map points, if I just look at a particular point, well, the K and the D impact the X point, and the A and the C impact the Y point, right? Because the A and the C are the up-down ones, and the K and the D are the left-right ones. They change the horizontal. Okay, so we can use this little formula, and you can sort of memorize the formula, but really, it's just if you know that these are horizontal, and you know that these are vertical, and you know that the A is a stretch compression and the K is a stretch compression, you're multiplying, right? And the fact that this one is X divided by K is because it has the opposite impact, right? So if it's a 2, that's a compression by a factor of 2. So you're changing the X values by dividing them by 2, right? So that makes sense. So you do have to remember that that this one you're dividing and this one you're multiplying. But again, I think if you have a good understanding, that should be pretty easy to do. So how do we use this? For example, example 1 here, the ordered pair 3, 5 belongs to the function y equals f at x. So we don't know if that is a quadratic or an absolute value or something else. The sine function we don't know, and it doesn't matter. Map it to each of the following. So we got to do a few things here. First of all, what I'm going to do is I'm going to identify my values. So I don't have a change in A. I don't have an A value. I don't have a K value. They're just 1, so I'll just leave that. What does D equal? Sorry? 1, good, positive 1. And what does C equal? Yep. Good, negative 5. So that is a horizontal shift to the right 1 and a vertical shift down 5. Right? That's how you would describe those transformations. That's how you would say it. So that means I'm going to take a point x, y, and I'm going to map it to x plus 1, because I add d, comma, y minus 5. Okay, so the particular point, 3, 5, maps to, what? Write it out the long way once. You wouldn't normally have to do this 5 minus 5, which equals 4, 0. Is that familiar? Did you do that last year? Yeah. Yeah. Okay, you can go ahead and try this one if you want. Do it the same way. Think about what values you have. A, K, D, and C. Think about what that would do to a general point. And think about what it would do to a specific point. So we've got an A value of negative 3. So that is going to do x isn't changed, and it's going to be negative 3 times y. So 3, negative 15. Okay, who can tell me what the A value is for C? Yeah. Negative 1. What is the K value? Somebody else? 1/3? Or 3? I guess it depends on how you do it, but the actual K value is 3. It's going to have an effect of 1/3, but my K value is 3. What about my D? Is that a trick question? No. Basin, what do you think? There still is a value. Has a value. 0, thank you. That's important because, like, sometimes that comes up. Just because a term is missing, like, there's still a coefficient there, or there's still a constant there. It just might be 0. So we don't write it, we don't worry about it. And then C is just 2. Okay, so this is going to be x over k, which is x over 3 plus 0. You don't need that. Like, you don't need to do that part. You don't need to show it, but it's important to be able to answer the question that is there. Like, we don't need to show it, but you should be able to say, well, D is 0, right? And then negative 1 times y plus 2. Okay, so 3, 5 goes to 3 over 3 plus 0, negative 5 plus 2, which is 1, negative 3. Good? Any questions? Yeah.
Would we have to go through that whole process on the test?
if you are asked to show how an equation, what impact it has on a general point, like x, y, then you would need to show it like this, right? Like you need to be able to, that's a skill you should be able to do, is do it to a general point. If all you were asked was to figure out that it was 3, 5, then it's probably a 1-mark question, so you would just do the answer. But I think it's important to be able to show the work, especially what if I asked you for a harder question that had fractions in it or something, or something else in it? Like what if it had, what if your point was x plus 2 comma y minus 4 or something weird like that? Like you want to be able to show the steps. So I would, if I was doing my homework, I would do it that way, showing my work a bunch of times, but then maybe streamline it and just do it in one step in the end kind of thing. Yeah. Okay. The first couple of these will be a bit, well, the first one, we'll figure out how to do it, and then the next one's going to be really easy. It's almost the same, and then a couple of them are a little bit tricky, but it's kind of repetitive. So let's get to it. For each of the following parent functions, state the equation of the transformed function defined by all that junk. So again, this is a general function notation. If I apply it to a parent function, what does that look like? 3 bracket 2 bracket x plus 2 bracket bracket squared minus 3. Looks a lot like the general function notation, but you got to include the squared. That's what makes it quadratic. It's now a specific function. Okay, you do absolute value. Okay, does that look all right? What if I wrote it like this? Is that right or wrong? See, yep. So what is not being factored do? Yeah, what does it do? 100? Yeah, it essentially doesn't show us the proper d value. Like it doesn't show us the right shift. Okay, so it's not factored, so it's not showing us transformations, but it would be the same relationship. It would be the same graph. Good. Okay, next one. This one can be a little bit trickier sometimes. There's a couple of different ways I can see that you might write this. You can try it if you want. Okay, yeah. All right, so one way I could write this is 3 over 2x plus 2, and again, I could write that in factored form, which is, I think, sort of the better way to write it, especially right now, but, you could write it either way, minus 3. Some people might like it a little bit better, or it might show up a bit more if it's 3 times 1 over 2x plus 2 minus 3. Same thing, right? But it's a 3, like fraction math. Everybody loves fractions. Like multiplying by 3 is the same as the 3 in the denominator, right? 3 times 1 be the same thing. So that shows the a value a little bit more, but it's the same idea. I think some people could get confused by that. Or what if I even wrote this as like a 3/2 somehow, move that out, right? It's the same idea, but it might look a little bit different, something to get used to. Okay, again, this one could be a bit tricky. Three times exponential function is a bit of a different one because people don't realize that this is part of the parent function. It's not a transformation. If I change that to a 3, that's not a transformation. That's changed the parent function. We lump all exponential functions together, but really you've changed the function, right? Changing the base. They all have similar properties, so we lump them together, but you've changed the parent function. So that's still just 2, right? That's never going to change. And then what's going to be my exponent? That's 2x plus 2. Okay, and what is it? Minus 3. Okay, so let's finish this up because the last couple I think are pretty straightforward. But the point of this is you should be able to recognize the transformations no matter what form they're looking at. You should be able to identify them, describe them by name, like look at this relationship, this exponential function, and say, okay, so it's got a vertical stretch by a factor of 3. It's got a horizontal compression by a factor of 2. It's got a horizontal shift to the left 2 and a vertical shift down 3. And every single one of these has the same transformations, different parent function, but right, because we're doing the same function every time. But that's the point of this, is recognizing what it looks like in the actually algebraic equation and then how that would translate to the graph. Okay, so this guy's probably pretty straightforward. 3 square root 2x plus 2 minus 3. This is called a tail. And it's useful when something comes after the square root sign because it shows you where the square root ends instead of people just like going like this and their pencil kind of trails off and you don't really know where it ends, right? So if you can't be ambiguous, if it's not clear, that's no good. And then y equals a sine bracket 2x plus 2 bracket minus 3. Any questions? So recognize them in the formula, describe them by name. Okay, and let's take a look at a couple of these kinds of questions. So in each of these graphs, the orange, I don't think, if you don't have this printed out, don't try to sketch it. I don't think that will help. So if you printed it, that's fine. You can do it, but sketching it's not going to help. So you can just watch and do the thinking along with the rest of us. The orange function is the parent function for reference. And the purple function is a transform function. So we're supposed to be finding the equation of the purple function. Quadratics, it's easy. We're so used to these. And it's got that vertex. It's like the anchor point, right? It's so easy to pick it out, and then I know exactly what my values are. So one nice way of doing this, if this is easy for you and you can just blow through it, that's fine. But if you want a little bit of structure for your thinking, A equals, K equals, D equals, and C equals. You write those down and you're like, okay, I got to figure out the value of each of these. So it looks like D is 3. It looks like C is -4. So again, I'm gonna fill in the blanks here. Y equals A bracket K bracket X minus D bracket squared plus C. So Y equals blank because I don't know that. Let's see. D, so X minus 3 minus 4. And this can be tricky. How do you, so there's no single necessarily one answer to this, but here's a way that should normally work if you're not sure. So where are the perfect points? I went over 1 and up 1. I went over 2 and up 4. So I'm going to like look for where those points might have gone to. So, there's a point here. Follow it along. There's another point there. So instead of going over 1, I've gone over 2 from the vertex. So what have I done? I've stretched it, right? I've stretched it horizontally by a factor of 2. I'm assuming the next point is usually over 2, but it's actually over 4. So what's my k value? It's a half. And then same thing, I usually go up 1, but I've gone up 2. I usually go up 4, but I've gone up 1, 2, 3, 4, 5, 6, 7, 8. So it's been vertically stretched by a factor of 2 as well. It opens upwards, so it's positive 2 and a half. So find some nice points that you can determine exactly where they are and think about how it's changed from the parent function. And you may not have seen this before, but I use this notation when I talk about it in grade 10. With quadratics, I go over 1. What do I go up? 1 squared is 1. Over 2, up 4. Over 3, up 9. Over 4, up 16. Like, look at that. It is a quadratic relationship. They're all squares. They're all perfect squares. I'm literally listing the perfect squares. 5, 24, 25. I'm listing the squares. And what's the relationship? Squaring. Quadratic. You're squaring everything, right? It's right there. And then you think about what changed here? The overs changed. Instead of over 1, I went over 2. I went over 4. I'll go over 6 for the next one. So you can see the change in the overs. That's a horizontal change, right? And same thing for the ups. So that can help too. Break it down into its parts. Think about the parent function. What's different? Okay, so what about this one? Here's my normal. I go over 1, up 1, and then I go over 4, just because that gives me a nice round number, but I only go up 2 because the square root of 4 is 2. This is a square root function now. And then I go over 9, and I only go up 3 because I take the square root of 9, and it gives me 3. Okay, so there's my shift. And I go over 1, up 2. 1, 2, 3, 4, up 1, 2, 3, 4. So instead I've gone up 2, up 4. What do you think is going to happen next? I'm going to go up 6. I go over 9, and I'm going to go up 6 to get to that point. So the overs haven't changed, but the ups have. So how would I write this one? Y equals 2 square root x plus 3 plus 3. Does that make sense? Yeah.
Why was it on the quadratic that k was a half?
Because we're stretching by a factor of 2,
Yeah.
but that makes the k value half. It has the opposite effect of what you would expect. Right? Yeah. Okay, one more. Ooh, these are even trickier. We're doing 2 units on trig, but they happen later in the course. So we talk a little bit about trig right now, doing some of this function stuff, but then we won't see it again for a little bit. So the green curve in this case, the colors change. The green curve is our parent function. Okay, there's one cycle. And the, whatever that is, orange or red, is transformed. So we do the same thing. What is A? What is K? What is D? What is C? I don't know what you remember about this from grade 11, but the phase shift, which is my D value, my horizontal shift, we call it a phase shift in periodic functions. It depends, right? Like you can shift both ways. Because it's periodic, I can keep shifting it and it becomes the same thing. So I'm going to keep it simple though. And I'm going to say, okay, first of all, I'm going to find the 0 line. What do you call that? The axis? You guys call it the axis. I call it the 0 line. So I'm going to find the 0 line. That's like the midpoint between the max and the min. Okay, so here's the max. What's my, that's at 1, I think. 1, 2, yeah, and that's the min is -3. So find the middle of that is 1, -1, sorry. So that's my shift down. C value is -1. And then I'll find a point on that line because sine curve starts on the 0 line or the axis. So I'll pick that point, and what is that? 30. It's counting by 30s. So my D value is 30. And then my amplitude is 2, and it's not changed. And, oh, my period has changed. Let's see. So I go... So that's 30 to 150. So that's 120. So how do you find that? You do 360 divided by 120. So it's 3. So y equals 2 sine 3 bracket x minus 30 bracket minus 1. Any questions? Okay, just for kicks, I don't think you need to write this down, so just watch. If I could also have chosen to shift it that way. Here, let me do this in a different color. Oh, no, that'd be bad. Green. Okay, so that would make my D value -30. And I would have had to flip it, right? So I don't know how much of this you remember. The only reason why I want to say this is if you get an answer and it doesn't match the back of the book, you might not be wrong. Okay, you might actually be right. You've just done something different with the flips. Okay, I have a handout here for you. I want you to do that. I only have one per 2 people. So take one between 2 of you and pass them back. And what you're going to do is just figure out the equation, basically. Okay. So I wanted to print it out because you might need to write on it and count the, like take a look at the scale. It's not supposed to trick you. There's a change. There's like the scale's a little bit different. So look carefully and figure out for me if there is a vertical stretch or horizontal compression. Which one does it have? And so then what does that make the equation? Okay, see if you can figure that out.